Hi folks, so this is a little video that's going to show you how we're going to make some links into GCSE paper 3 and how we're going to link that through to what we've just been looking at the downstream changes. So the first thing that I need to say to you is a reminder that your GCSE geography is split into 3 papers. Paper 1, which is the one that we do in year 11, is all about the physical geography. Paper 2, which comes in year 12, is all about human geography, what it's like to live in our planet. But in between the two, we sneak in a little bit of a paper 3 towards the end of June of year 11 and into September of year 12, and the most important thing to say right at the start is that involves the field trip. That's the day that we go out, we put our wellies on, we go up the Colin River in Belfast, and you go and have great fun seeing geography happen in the real world right in front of your very eyes. But the data collection, as you can see here, is only one part of that process of geographical inquiry. And I'm just going to quickly overview this with you now to see how things are sitting in with this. What we'll do before we go on the field trip is to plan things out. So things like setting our hypotheses, we're going to practice collecting the data, what are the methods you need to use, what are the instruments. Then we're going to have our day out in the river doing all of those things. We're going to use GIS to collect the data, so the presentation side of things that we'll do is going to be exciting and have a 3D GIS maps and all sorts of things like this. What you'll discover though, that in GCSE paper 3 we have to go a wee bit old school. We have to go back to a pen, or a pencil actually I should say, a piece of paper and drawing graphs by hand. So that's really what this is going to be focusing in on here. This is the presentation side of things. Then you're into this little section here on analysis and interpretation. Those are just fancy words for the writing that you'll do to describe the graph, that's your analysis, what is the graph showing, and to explain the graph, that's your interpretation. Then we'll go on and look at conclusions and valuations. We'll not do those today. So the big focus in this little section here is these two parts, the presentation and the analysis and the interpretation. So the first thing you need to do is to take a look at this little part in your book. So if you turn to that page, and I'm just going to crop this down a little bit, because what we need to do is to focus in here much more on this little graph here. And if you see the question at the top of this, this is a very, very common question type for questions like this. Now, first of all, we'll notice that the command phrase here is describe. And when you're describing something, you're asking what is happening, what is going on. And it is important that you read those command phrases and see the difference between what you're being asked to describe something, what's happening, and explain something, why is it happening. Then the next thing you need to notice here is what are you being asked to describe? It's the relationship between width and distance from the source as it's shown in the graph. So it's the relationship between those two. So how do you go about describing that relationship? The first thing that I want to do is to give you a little bit of a tip. Here comes an exam box tip. Again, this is in your book. So here's your exam box tip, and this guides you through. You start off by taking a look at the trend of the data. So you start by stating the trend. Then you need to quote figures, because you always need to have evidence for what you're saying. And then something anomalies. We'll come to those in a moment, but we can abbreviate that down to T, F, A. That is a good opportunity for you just to look at those and remember that you need to be dealing with your trend, your figures to quote evidence, and any anomaly that there is there. Now, take a look at the sample graph here for you. You've got dots, which are the points of data, and you've got a line. I wonder, do you know which one of those is going to represent the trend? Yep, of course it is. It's the line. That's the thing that you'll start off with. What is the trend? Now, for any trend, what you will then need to do whenever you're describing it is to use a verb and an adverb. So for your trend here, I'm saying that this is rising. Right? It's starting low and it's going higher, so it's rising. and it's rising, I would say that's rising reasonably gently. It's a gradual increase on the way up. Now, that is our trend. It's rising gently. Then we go in and get our figures. So at the very least, you're going to need to quote a figure from the start and a figure from the end. So you're going to have a couple of figures quoted. That's the figures done. And then the anomaly. Now, what is an anomaly? An anomaly is something that stands out from the trend. This is a point that is not close to the line. It's not close to the other points. This is a point that is very much doing its own thing. Can you spot it? Yeah, I'm sure you did. There it is. There is your anomaly. And again, what you'll need to do is to quote figures. There's your distance from the source, and you get those across. So that is your description. Trend, figures, and anomalies, if they exist. Anomalies don't always exist, but if they exist, you need to point them out. Okay, if you then turn over in your notes to the next page, what you will see is a space for you to do just that. We'll just paste this in here so you can see it. Now, what I would like you to do now, based on that graph, is to take that piece of instruction that I've just done with you there. Trend. What's the overall trend? Rising gently, so giving you the clue. There you go. The figures from the start, figures from the end. This is distance from the source. This is your width in meters. And then your anomaly. And that's what you've got to do in there. So you can see how the marks would be allocated here. For the marks, you're going to have a mark for stating the trend, a couple of marks for the figures, and then a mark for the anomaly at the end. So can you pause the video now and have a go at writing that up using that little guidance to help you there? Okay, so let's then come back and just check in with our process of geographic inquiry. So we've done the analysis, we're describing what the graph shows. Next up, it's time to move on to our interpretation. Why is it doing what it's doing? So let's have a look at the question. Again, what you need to be doing is circling the command phrase. In this case, it's explain. If describe is what? Explain is why. Why is the relationship the way that it is? Why does river width increase as you move downstream? Explain the relationship. Again, 4 marks for this. We're looking for some detail here. And this is your exam tip. You need to refer to the theory in your notes, and you need to include key terms for this as well. Now that takes you back into some of the previous notes that we did, including some of the previous videos where, especially if you take a look at the video on the Analong River and the changes downstream there, about why it is that the river is getting changing as you move downstream. But I'll give you just a quick little reminder at this stage, just to remember why this is the case. Why does the river get wider as you move downstream? Here is a quick reminder of what the theory should tell you. Right, so I'm going to just draw a very quick river landscape of somewhere that is similar to show you what a river will be like as you move downstream, and we enter into the water here. So we'll just draw that on, just a very quick sketch, and here comes our river. So as it comes downstream, you get a number of these tributaries joining together, but as the river comes down here, it starts to meander. So why is it that the river gets wider as you move downstream? Well, one of the key points here is that as each of these tributaries joins in, you get an increase in the amount of water in the river. You get an increase in the discharge, in other words, in the river. And because of that increased discharge, that gives the river more energy. Because the river has more energy, that's going to lead to erosion. Now, remember, there are 2 directions in which erosion takes place. You can have your vertical erosion, you can have your lateral erosion. Now, of course, we're looking at river width here, so when it comes to width, the erosion that we're particularly interested in is the lateral erosion. Okay, now you can see there that there's terms that you can be using. Discharge. I also talked about tributaries. You can talk about confluence, energy, lateral erosion. Plenty of terms for you to include to explain that. So it's time to pause the video again and take a few moments to write that answer down. Okay, so now that you have described your trend and your included your figures and your anomaly, you've described that. You here have explained the trend. So you will always explain the trend with reference to your theory. So there's the theory for that. The final little question down here is this one. Because, of course, don't forget our anomaly. There is one anomaly here in this river. Identify it and suggest a reason for it. Okay. Well, identifying it's reasonably easy. We've done that already. There is the anomaly. It's survey site number 2, and you'll be able to get the figures read off the graph for that. But why is it that rivers might not be quite so wide in a certain location compared to some others? I'm going to offer you a couple of possible suggestions here that might help to explain that with reference to a river coming down here. One of them is to do with a natural factor to do with the geology. So it may well be that in this case you're going from somewhere where you have a harder rock to somewhere where you have, a softer rock to somewhere where you've got a harder rock. Here we have it. And then as the river comes downstream, what will happen is that in the softer rock it finds it relatively easy to erode laterally. But then when it comes into the harder rock, maybe it doesn't erode laterally quite so easily because the rock is harder and it will get a little bit narrower there. So if a river flows through different areas of geology, that can affect the rate at which the erosion is taking place. So that's one reason why, a natural reason. But there might also be a human reason why. Whenever we're finished this section, we'll be moving on to human management of the rivers. And one of the things that humans will maybe do sometimes is to try to protect rivers and stop them from eroding. And we're going to discover that's actually totally the case in the Colin River. There's one particular area where the river comes down like this. It's reasonably straight in the area, but the Colin Glen is an area where a lot of people go for walks. It's like kind of like a forest park, and there's an area there called Tribridge. Called Tribridge because it has 3 parts to it. This is a bridge over the river. Now, this bridge is going to cost tens, maybe hundreds of thousands of pounds. This is certainly not something that you want to see getting damaged and destroyed. And if the river is coming down here, and if that river is eroding laterally, as rivers do, what it might do is undermine the foundations of the bridge. And the people that have built this bridge absolutely don't want that to happen. So what they will do is put boulders at the side of the river here that are designed specifically to stop lateral erosion from occurring. Now, as a result of that then, at this one particular location, the river may not be quite so wide. And this is, in the case of the Colin River, this is Tribridge. Okay, if we go back up here to where we started, what we said was that you need a trend, you need figures for evidence, and you need to identify your anomaly. If there is one, there won't always be one, and we absolutely see that in this case. You then need to go on to analyze and interpret it. What's it showing and why? So we described that, and then we moved on to explain it in relation to the theory. This was the theory of why rivers get wider as you move downstream. Then there was an anomaly here. There's not always going to be an anomaly, but there was one here, and I've suggested either a physical reason for it or a human reason for it. And that's how you go about doing this little bit here of your analysis and interpretation. Now there's one final thing that we need to be doing in here, and that is to do with your data presentation. Once you've collected your data, as I say, in our actual field trip we're going to be using GIS, and it's going to present it for us really quickly. You can draw all sorts of exciting graphs and map them all over the maps. We're going to have great fun with that. In the actual exam they can't at the moment accommodate the use of GIS, so we're going to have to hand draw the graph. So if you turn over to the next page in your notes, you will see that there's graph paper there for you to draw the graph itself. You should be used to drawing graphs in science. The geographical process of inquiry is very similar in many ways to the process that you'll carry out an experiment with. So once you've collected your data, you then have to draw your graph. So what I want to do is to show you how you're going to go about doing that, and then the series of exercises that come after that just allow you to practice over and over and over again. So you see up at the top here we've got distance from the source. So what you need to do is to take a look at the biggest number. In this case it's 5.6, and then we're going to count the squares at the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. So rounding that up to the next whole number, that's 6. So with a ruler, now I don't have a ruler here unfortunately that I can use on my computer screen, so I'm just going to have to try and draw this on by hand, but you come over there. So you draw that over, rule that out please, and then you will start to label it 1, 2, 3, 4, 5, 6. So I've run out of room. I should have spaced that out better. You need to write the numbers on there. So you need to put the numbers down there. Numbers 1 to 6. And you need your units. Distance from the source in kilometers. So we put in kilometers there. Then you do something very similar for the depth. So we're looking here at the depth in centimeters from 8.5 up to 16.9. So rounding that up to the next highest one, it's 17. So then we've got to decide how we're going to fit this in. So let's count the squares again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 square can't equal 1 centimeter because we've got to get up to 17, and there's only it only goes up to 10. So what we're going to do here is make 1 square equal to 2 centimeters. So 2, 4, 6, 8, and so on, 10. You can do this much more neatly than I can do. Oh, I can nearly count in twos. 12, 14, 16, 18. And that means that both of those axes, the one along the bottom, is big enough to contain all the distance numbers, and the one up the side is big enough to contain all the depth numbers. And it's just simply a matter then going along and plotting those. So distance from the source, first one is 0.8. Now again, you can do this much more precisely than I can on a computer screen. Well, that's coming up there. And it is 8.5. So we'll put an X, again, as precisely as possible. You will be much more precise than I am. That's awful, but it's the best that I can do on the computer screen. You need to plot it very, very carefully and very precisely. Then the next one will be 4.5. So you're down at the bottom here at 0, 1, 2, 3, 4. So 4.5 halfway across, and again you're coming up there and you're going to plot that from here, 13.5, and again you will need to be much more precise than I am. So you'll go through there and you will plot on all of your points like that. And you can either just leave it like that as a scatter graph, or you can join the points with a line. Then the final thing you'll need here is your title. And the title in this case, I've drawn a line graph, so it's going to be a line graph showing depth and distance from the source. Now, just realised there's one thing, of course, that I forgot to put on here, which is to label the axes, and I need to have here, again, the same thing, distance from the source, and we've got the units there of kilometres, and up the side here, we've got depth. Again, you can do this much more neatly than I can do on the computer screen, in centimetres. So what you will need to do for your graph is you'll need your title, you need your accurately plotted points, and you will need to label your axes. Okay, so we come back to where we started here. We looked at our whole process of inquiry, and what we have done here is figured out how to go about presenting data, how we need to draw the graph, how then to analyze it, say what it's saying, and to interpret it. So if you look at the next few pages in your notes, what you get a chance to do now is to practice this. Now that I've modeled for you the approach to take, you will get better and better at this and these kinds of skills if you practice. So it's just a matter of using the guidance that I've done with this and going through the rest of those and practice, 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 because practice, as long as you do it right, will make perfect.